Okay, guys, we need to start studying. People are here and we need to start. So last class what we did is we were talking about communication methods. We'll just do a quick review of that and then we're going to move into the new stuff. So we talked about this thing called bandwidth, yeah? And AM and FM, right? Basically we talked about how signal communication happens and different ways of doing it using wires and doing radio frequencies. And then we studied about how you basically have different sorts of problems with directly communicating or modulating the signal itself. So then what we did is we figured out there's different ways of modulation to be done. So what are the different ways of doing modulation? You can have amplitude modulation, which is basically this. The amplitude varies in synchrony with the displacement of the information signal. And frequency modulation, where the frequency varies in synchrony with the displacement of the information signal. So these are the different things that we studied. Moving on, then we studied about bandwidths and stuff, right? So basically you have these side bands, basically bandwidths increase and decrease. We studied about this, and this leads to a bandwidth which is FC plus minus FA. This is an amplitude modulation.
How do you find out bandwidth?
Well, all you need to do is basically find out how much your information frequency signal is. So the information signal's frequency is. Once you find the frequency of this, you basically multiply this by 2. So if this is say 4.5 kilohertz, then the bandwidth is going to be 9 kilohertz. Okay. So as simple as that. Easy peasy.
Information signal
frequency. What? Huh?
Information signal frequency.
Yes. Okay. All right. There we go. All right. Moving on. Then we talked about the advantages and disadvantages of AM and FM communication. We talked about how AM is better because it's cheaper. You can fit in more bandwidth, fit in more stations, and also it has greater range. But FM is better in different ways. FM has less chances of picking up noise. FM's bandwidth is wider, so the quality of the signal is also better. So different ones have different advantages and disadvantages based on basically what we do and how we do it. All right, so today we would need to go on to the next part of communications, which is basically we'll talk a little bit about satellites and stuff, right? So if we talk about satellites, what do we have? First of all, one of the first things that we need to study about is the concept of how uplinks and downlinks have different frequencies. And because they have different frequencies, why do we actually give them different frequencies? That's the number one thing. So say, for example, if we were to, one of the most common analogies I use, say, for example, we use blue light to signal something, say something which works on light, all right? So say this receives a beam of blue light from really, really far away, and then it starts emitting blue light in all directions. Now this is going to be a problem. Maksud, can you tell me why it's going to be a problem?
Because it's probably going to be picked up by the receiver.
The thing itself is going to get messed up. Leaving? Yeah, okay, Monmo is leaving us tonight. Good night, take care, thank you for your time, have a good time, and bye-bye. So basically, this is one of the issues. So how would you solve this, Maksud?
Probably use a different frequency.
Yes, we would use a lower frequency, right? So that what happens is if it receives blue light and then ends up emitting red light, one of the things is it won't interfere with the blue light, right?
Yep.
So that would basically mean even if it emits red light, you'd still be able to see the blue light approaching it, number one.
And pick it up.
Yes, see it, detect it and pick it up. And then you can send the red light down the signal. So the advantage of this is you don't swamp out the uplink signal by sending out the same frequency. So what you're preventing is this thing called swamping. So you prevent this so that the signal doesn't get blocked out or anything. So yes, that's basically what goes on here. Transmitting station, blah, 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 blah. If you read this, you're going to see there's a frequency up and there's a frequency down. And these have different values. They can be 6 and 4, up being 6, down being 4 gigahertz. They can be 14, 11, basically the same thing, up being 14, down being 11. And we have 30, 20, where 30 is up, down is 20. So yes, so these are the different types of frequencies. This is a very, very common question that they ask whenever they ask about satellite communication, and you have to specifically answer to prevent the uplink being swamped by the downlink, which is emitted by the satellite. So that's one of the things you need to know. All right, moving on. We need to talk about different types of orbits that satellites can have around the Earth, right? So number one is this orbit called polar orbit. You can see that, right? So polar orbit is this really low and really fast orbit. It's pretty cool because you can actually see, have you seen the NASA live feed?
Yeah.
Huh?
Yeah.
It's so cool. Have you seen the NASA live feed?
No.
It's this amazing thing. Yes, the International Space Station. So
you can actually track it.
All right, guys, back to this polar orbit. Basically, this is something that the International Space Station does. So what goes on is basically, if this is the Earth, okay, do we have a ball to represent the Earth? So basically, say this is the Earth. So what polar orbit does is it keeps rotating, but because the Earth is also spinning, it ends up covering all of the parts of the planet, right? So that's basically what happens. And as this goes on, it eventually covers the entire planet. So these are low orbit. Basically, it does one complete rotation in about 90 minutes. And another crazy thing is you can actually use it to take photos of the surface of the planet, and that's how Google Earth works. Google Earth exactly does that. So, so this is a low orbit 90-minute rotation, and it within 90 minutes, because the Earth rotates by 23 degrees, you basically have the Earth rotating a little bit more with every rotation. So you end up mapping out the entire surface of the planet. And there's one really good thing about polar orbits is that it covers literally the entire surface of the planet bit by bit, bit by bit. So, point is that polar orbits and everything. So why do we? One of the major problems with polar orbits is you only can use it when the satellite is above the horizon. So if you're standing here, the satellite is going to stay above the horizon only for a fraction of its flight. Then it goes beneath the horizon again. That's when you can't use it to communicate. So you're going to need a chain of polar orbit satellites, so that before one goes beneath the horizon, another one comes up to take its place, so that you have an entire network. And due to it's ridiculously expensive and ridiculously impractical to have such a sort of polar orbit satellite network, guess who does it?
Google.
America, Department of Defense. They have 1,000 satellites up there doing exactly this, tracking everything, every motion and everything. So another orbit is geostationary orbit. So geostationary orbit is basically this. Interesting thing about geostationary orbit is if you use, say, 3 satellites to do geostationary orbit, you end up covering the entire planet with just 3 satellites. And it's actually possible. But the only disadvantage of using geostationary orbits is it just misses out 2 regions of the planet.
Yeah.
Yes, it ends up missing out the poles. So basically, geostationary orbits cannot cover what's at the poles. That's one of the major disadvantages of using geostat satellites. So there are a number of requirements for a satellite to be geostationary. So number one is it only happens at this radius, and the reason that happens is because this is the only radius at which the satellite's rotational time period is equal to the rotational time period of the Earth. So we do this calculation using 2 equations. Can you tell me the equations we used to do this calculation?
GMM by R squared.
Yes, one is F is equal to G M1 M2 by R squared, and what's another one?
It's MR omega square.
Yes, F is equal to mr omega squared. It's still...
Gravitational force.
All right, moving on. F is equal to mr omega squared. So with these, you can actually come up with a formula, right? Where there's a relationship between the time period and the radius, right? It's called Kepler's law. Do you remember Kepler's law? No? Oh man, that's unfortunate. So the relationship between time period and radius. I'm giving this to you guys as a homework. Find out the relationship between time period and radius of an orbit. And it's this law called Kepler's law. You can just very easily do a little bit of research and you're going to be able to find out about it. All right, so basically, geostationary orbit only occurs when you have 3 things satisfied. Number 1, the orbit at...
R cube.
Someone's getting smart. Did you read that somewhere?
I figured it out.
Oh, all right, fair enough. So number 1, it occurs only at a specific radius, which is around 40,000 kilometers. 40,000 kilometers from the center of the Earth, all right? It only occurs at this radius, nothing more, nothing less. Number 2 is...
It's heavy.
Huh?
It's heavy.
Yeah, very savvy. I love my banana phone. Number 2 is it has to be rotating in the same direction. So if Earth is rotating in this direction, then the satellite also has to be rotating in the same direction. Basically, they both have to rotate in the same direction. All right. Ahmed Ismail Jubair wants Student of the Week.
What do you do?
Annoy me
It.
and believe Earth is flat. Like, well, he did say T square R cube, but like, no man, not enough. All right, so yes, that's the second point. It has to have same rotation. The rotation has to match. And number 3, it has to be above the equator. Technically, you can have a geostationary orbit above the Tropic of Cancer and Tropic of Capricorn also, but primarily we focus on being on the equator. All right, so moving on, there's a little bit of stuff here that you need to read through. And one of the most important things that you need to read through here is you need to realize that the distance that the Earth is from the satellite is so huge that actually you get a significant delay in the signal. So even if it's traveling at the speed of light, 40,000 kilometers does take a fraction of a second to go and come back with. So that's why what we basically do is we never use, say, one geostationary satellite and then another geostationary satellite and then another geostationary satellite to communicate to the Earth. Or like, we don't go like bump, bump, bump. That would make conversations really, really long. So that's why what we do is we never use too many geostationary satellites together. What we do is you use one satellite and then connect it with another satellite and connect it with another satellite, maybe one or two satellites, and then the rest we use fiber optics along the surface of the Earth to do the communication. So that does it much faster, reduces the delay. And even though the delay seems to be small, in reality, these delays are like, unacceptable, especially when you're doing phone conversations and stuff. So yes, that's geostationary orbit. It's already 11:30.
Yeah, because we started at like.
Yeah, we started a
10
little
or-
late. What I would like to do actually is I want to take one more day for communication. It's a big chapter. There's a lot of complex ideas.
Okay.
And next class, what we're going to do is we're going to talk about digital to analog conversion first. We're going to talk about the binary code, and in the end, we're going to talk about decibel attenuations, right? So like, we're going to talk about logarithmic scales and everything. This is going to be the stuff we're going to study tomorrow. It's going to be the last class we're going to do communication, and we will be done. All right, then guys, that's that for tonight. I hope you guys got that. I hope you enjoyed it. We did a lot of banter, maybe a little too much banter actually.
Not in this class.
But yeah, the previous one. But we also studied a lot in that one, right?
Yep.
Interesting,
We
very
got
interesting
that.
how we can efficiently get stuff done. We should actually do podcasts now, like show
Recording
bullshit,
podcasts.
like Earth is flat. No, it's not.